One more thing to confirm and we'll get started. So great, so let's get started, everyone. So welcome back to your first semester here. Welcome to the University of Utah, the fall semester. So I'm Jeff Phillips. I'm the instructor for the course, so Foundations of Data Analysis. Perhaps confusingly, it has 3 different numbers you could take this under in the in the catalog. Most of you are in the CS version, CS 3190. There's also a data science version. This is a required class for the data science major. There's also a comp version, so 5960-01. There's actually an O2 section because of some weird thing with the happened when they're creating the first class. So all these classes are meeting together. They're going to have the same lectures, the same assignments, the same sort of everything. So if there is kind of some big discrepancy in grades or something, I might grade them slightly differently, but we'll still talk about how that will work in the syllabus. So the first thing to point out is that this class is is going to be in person, right? So that's here. I'm also putting the course on Zoom. So there are a handful of people on Zoom, and it's being recorded as you get to all those from the links off the webpage. So I've been recording my classes for like 8 or 10 years. So something I've been doing for a while, because a lot of the classes I end up teaching, they're people who are working full time, who are also taking these courses. So during the pandemic, with COVID, it was great to have classes on Zoom, because then you weren't worried about, when there was a lot of fear about the more severe strains of COVID, and so we didn't have vaccines, that you may not have wanted to be in a classroom with kind of this many other people at the same time. What we found, though, was that, when some people have access to recorded lectures, they stop coming to class, then they stop always watching the lectures, and then they don't do as well in the class. They stop being engaged in the class. Usually early on in the semester, there's not as much new material. You kind of get into a lulled sense of security about the class, and you keep putting off on watching the lectures. So it was kind of a tough decision whether I would continue to put stuff on Zoom. And so YouTube, there are already people who are out with COVID, though. So it seemed like it was still the right thing to do, but I want to implore you to try and come to class. And if you can't come to class, try and watch the lectures as soon as you can afterwards. Either go online, watch them live on Zoom. You can interact on Zoom. I've got the chat open. I can usually watch the chat at the same time as class and respond to questions. So you can still interact with the class. And then, so TA Anna is up here. She's also going to be monitoring the chat. So if there's kind of questions that are coming up, we can also do that and be interactive. If you delay watching the lectures, you're going to fall behind in class. And so, you know, I'll probably try and give this warning later on, but right now you're all here, right? So if I give this warning and you're not here to listen to it, then it's not going to help. Okay, so please try and stay on top of things. So also because it's being recorded, this is a public campus. During the day, this is a public space. This is a public recording. If you end up getting something recorded you don't want recorded, you can let me know and maybe I can edit it. This has happened once in about 10 years of doing this. But so just be aware of that if there are any issues with that. So you're just being given some notification about that. So that's okay. So the plan for the rest of this class is then, so with most classes on the first day of the semester, we're going to go over the mechanics of the class. I hope to, the second half of this, give you a preview of kind of all the material that's in the class, so you can get a sense of what's going on. So let's get into the preview of the class. Okay, so the two most important things to stay on top of the class, you need to pay attention to the web page. You can see the URL, so you can't see it too well up there, but it's so it's posted on Canvas. So you should pay attention to this class web page. It has the schedule for the whole semester on it. This is really important. You'll see on the date. I'll link to the video in case you missed the class or you want to go back and watch the video or part of the video. I will link, I'll be writing on my iPad and you all be able to see it on the board. And I will be linking to the notes I write on my iPad on this line. And occasionally we'll do some coding, some light coding in Python. I will link to that here as well. I will put the files on Collab so you can download them. You can play with them with just in the interface for this. You also see when the homeworks and the quizzes are for the class. When the homeworks are available, I will post them. I plan to post the first homework by next week, Tuesday. That's when I see homework 1 out, right? So they'll be linked off there. And then when it's due is in green, right? So you get to see everything here. This is also on Canvas. The homeworks are due on the date they're posted at 11:50 p.m. Canvas says a little bit later, that's my slack time, okay? So it's actually, Canvas says it, 11:59. It's late after 11:50. So if you turn it in at 11, at 1 minute past the Canvas deadline, it's actually 10 minutes late, okay? So start uploading by 11:50 and you should be okay. There is, the first quiz is going to be on Thursday. How the quizzes are going to work, they're going to be Canvas quizzes. Okay, you can do them here. If you bring your laptop, you can do them here in class. We will end class half an hour early on the days we have a quiz, and we'll do them here. That's great because I will be here and Anna will be here to answer questions on the quiz. There are usually some questions on the quiz. We try and make them, so there's no ambiguity, but there are usually questions on the quiz. So ideally you should take it at this time, but they will be open until the end of the day. Okay, the first one is a warm-up quiz. It's basically, in case you haven't taken a Canvas quiz before, it's practice, okay? It's gonna be about, the syllabus, so I want you to read the syllabus, okay? So it's forcing you to read the syllabus, and it's practice with a Canvas quiz. One of the things we'll be doing in this class is we're learning about kind of data analysis, things like machine learning, and it's kind of a foundations class, meaning this class, as opposed to other ones we offer in the data science curriculum, is more focused on the mathematical understanding of it. And so part of it is learning the mathematical language used to describe machine learning algorithms, for instance, right? So you may have to write some mathematical notation in Canvas, and we're giving you a practice to do that on this quiz. I don't intend any of the other quizzes to have something as difficult as the simple equation there, but that's just practice. So the first time you're asked to do something like that, it's not as hard as what you do in the practice quiz. Okay, so that's a little bit about what the quiz zeros is going to be about. It's also worth less than the other quizzes. So don't worry, no sweat on that one. So other important thing, we have 5 TAs and TMs teaching some mentees for this class. Okay, and the office hours of all of them have been posted. So if you have, I've distributed these throughout the week, and they are trying to be at some different times of the day. Some in the morning, some in the afternoon, some in the late afternoon, right? So most of all the homework are going to be due on Tuesday evenings. So most of the TA hours are going to be on, they're clustered more on Mondays and Tuesdays. I kind of know from experience that a lot of people have questions right before the homeworks are due. Okay, so there are 2 on Mondays and 1 on Tuesday. They're all on these 2-hour blocks. The TA hours are all going to be in Web 2426, which is on the upper part of Web. It used to be a study room. School Computing's regular TA space is under construction this semester, so we've secured this room. My office hours are going to be, I'll be here right after class or in the area out there. And also in my office on Thursday morning. My office is currently MEB 3404. It's right next to the main office. Okay, but at some point during the semester, my office is going to move. They're doing this crazy roof construction, and I'll move down the hall to another faculty's office who's on sabbatical this semester. So I will alert you when that happens. It was supposed to be the end of this week. They currently will not give me an update on when it's actually going to happen. I'm hoping it's not for a while, but so we'll have to see. All right. So what else about the course is going to be important? So this course is mostly going to be the mathematical foundations of doing data analysis. There's going to be homeworks which are problem sets, kind of like if you took the probability and statistics course or the similar course in the math department. I think that sort of problem sets dealing with some data. There is a very simple aspect to every assignment, but it's usually something we went through in class and then kind of modifying it, so you're kind of learning Python so as you go. All the examples and stuff we ask you to do, we recommend you do it in Python. We don't expect anyone to know any Python before this starts. So part of the class will be giving you some very introductory stuff in Python. It's kind of the most common language for doing this sort of stuff. So that's what we'll be using. One of my former TAs created a tutorial for loading and processing data in Collab. You won't need that at least till about halfway through the semester when we start loading actual data set, but there's some reference there if you haven't seen it before. At this point, when I first started teaching this, a lot of people had not used Python. Now I'm guessing most of you had used some Python in the past, but if you haven't, that's totally fine. The book for the class. Okay, so this is the book for the class. So it's a book I wrote out of creating this class here, along with creating the data mining class, which is kind of a more upper level course. And but it's structured based on the delivery in this course. Okay, it's so you're welcome to get this version. This version is a little bit nicer if you buy it. There is a free version online that basically has all the same material in it. It's not formatted quite as nicely. You can download version 0.6. The formatting is a little bit different. It doesn't have all the advanced material, and there's a few more typos and stuff in there. Okay, but it should work for you. If you want the actual book, you're welcome to get the actual book. But I'm not requiring you to buy a textbook for the course. Okay. All right. Any other questions about how the web page works? Right. All the homeworks will be uploaded through Canvas. The quizzes will be on Canvas, so if you aren't, you don't have to turn any paper in person. Yeah.
Is there a version of Python you would want to recommend, or just use the latest version of Python?
Yeah. Okay. So Python there's a weird thing about Python. There's a Python version 2.7, I think, and it got split. And then there's a version Python 3 and later. At the time when they split, it wasn't clear whether you should start using Python 3. At this point, you should be using Python 3, which is the most advanced version. There's a couple of changes in the syntax that won't. When they first split, it didn't matter. All the syntax was basically the same. It just didn't have the library support. Now the syntax has changed a little bit. So use the latest version of Python. If you do stuff on Collab, you don't even need to install anything. It's a web kind of interface for using Python on Google's servers. It's like a Jupyter notebook, but you don't have to install all the crazy stuff you have to install to run a Jupyter notebook on your computer. All right, so it's pretty easy. Yeah.
They're asking me about.
Oh, okay. Yeah, this was something I was going to try and get some feedback for. In last year, we did a few Zoom office hours, and most people still came in person. And I figured there'd be even less this year. If there is a desire for Zoom office hours, we can probably convert some or add some to Zoom. They're not all going to be Zoom office hours, and balancing between in-person and Zoom people in office hours is kind of tricky. If you catch someone and there's no one else there, it's fine. But when they're really needed, they're not. So we could maybe do 1 or 2 Zoom office hours, but they're not going to have the same coverage. So if you want Zoom office hours, please send me an email, and I'll try and judge based on the response whether there's sufficient response to try and make these kind of standard. I see that people on Zoom want Zoom office hours. So one thing I will do is my office hours. Typically, I don't have people coming to my Thursday office hours. If you want to meet me on Zoom, send me an email, and I will make sure I'm available on Zoom for those office hours. So I will definitely make those available. Whether we have dedicated TA Zoom hours, it'll depend on demand. Yeah.
Going back a little bit with the quizzes, are those labs done at home as a homework type thing, or are they in class?
They are. So what will happen, I will end class 30 minutes early, and they're Canvas quizzes. So most people have their laptops here. You can probably do it on your phone if you're pretty confident. Look at the practice quiz and see if you can, you can try that phone if you don't have a laptop or something. So most people do them here in class. Some people will find it'll be quiet space in class, and you'll be able to ask questions. That's what I recommend. But you can do them at home, and some people prefer to try and do them at home. That's fine. I've left them open until the day. Yeah.
So why did quizzes close till the day of?
Yeah, I don't want you to start taking the quiz before if the quiz is open for too long, it facilitates people cheating. I don't want people to cheat. All right. And so I've debated whether I'm open that long even, but that seems like a good compromise for people who have other constraints, and it deals with a lot of issues automatically that way. I do other things to look and catch and prevent people from cheating. Some of them I'm not going to say, but there are other mechanisms in place to prevent, to try and keep people from cheating and catch people if they do cheat. Please don't cheat. It's not worth it. The consequences are way worse than the advantage that you get, okay? People get caught cheating every semester. It basically ruins their life, okay? It's not worth it, okay? Yes.
So are the quizzes like alone or together?
The quizzes are alone. The quizzes are alone, yes. I will discuss, I'm going to go through the syllabus next, which does a little bit more of this policy. Yeah. Yeah, like I said, if you're having trouble, you feel you're falling behind, and you feel like you need to cheat because you're going to fall behind anyways, come to me, okay? I'm happy to try and find a solution that does not end up with you falling behind and failing the class. I do this every semester for students. I feel much better doing that and knowing that I'm willing to help you out if you're falling behind than feeling like you put in a position where you feel like you have to cheat, okay? So if it feels rough, come to me. I will try and figure out a way to get you through that. Okay, that's so great. Okay. Okay, so the syllabus, PDF syllabus that you can, this is a kind of somewhat of a contract between us and the class. If I update the PDF syllabus, I will explicitly let you know. Otherwise, it should be more or less frozen. Kind of learning objectives. We'll kind of go over that a little bit. I guess the book. Yeah, so you can get stuff on Zoom and stuff. Ask for help. Okay, so if you post, the discussion board for the class will be on Canvas. I will try and I want you to ask for help there instead of emailing me directly about homework questions or quiz stuff. But do not put specific possible answers in there. We'll have to take those down. And we'll try and respond very quickly on Canvas. We're usually pretty good on staying on top of these questions. I hope you don't feel shy, but this is for the good of everyone. Everyone, if you have a question, almost assuredly at least 10, probably 20 of the people have the same question, okay? So please post questions so that you have there. If you do have a question kind of like, I think I'm on the right track, but I'm not sure, those are great for the help hours. And sometimes you can email me or one of the TAs for that, but that's not something appropriate to post on the discussion board because it's giving other people help towards the answer that they should be working out themselves. Okay, prerequisites. So kind of the core prerequisites is not, the programming is kind of in there to make sure you're far enough along in the program if you're a CS or data science student. We have linear algebra as a, we have linear algebra as a prereq in the, as a prereq in the course. The first couple semesters I taught this, I didn't do this. I said, we'll see how people do. And they felt more comfortable having taken linear algebra. Some people do perfectly fine not having had linear algebra. I know for the 5,000 level course, there are no prereqs. And some of you will be learning some linear algebra in this course. We're not learning all of linear algebra. We're kind of learning how to represent data as vectors and matrices and some basic operations. So we will get 3-lecture review of that, how to think about data in terms of linear algebra, but it's also a review of linear algebra. So if you haven't had that before, but you feel like you're an advanced learner, you should be okay, but that's why it's there. The probability and statistics, we'll also review the core parts of this. This is a co-req. People who've had this, who are advanced in this or feel comfortable learning this stuff might be fine if they haven't taken that yet. Those courses cover different things than is in this course, but this is the core, most of the core of what you need to understand things for, so for advanced machine learning and so forth in data science. And the machine learning we'll do in this, so in this course. Oh, there's a question on Zoom about, I just saw now, will the final exam be done in person or will it be available on Canvas? I haven't decided on this yet. Last year I did it on Canvas, but There was also a lot more, I'll say more about COVID in a few minutes. I was a lot more concerned about COVID last time I taught the course. So we'll see. I haven't decided yet about the final exam. I might have that in person. It might be a Canvas quiz. Okay. All right. So the grading in the class, the homeworks are 60% of the total grade. Those are there for you to learn, and that's probably where most of your time in the class, outside of class, will be in reviewing material and solving the homeworks. The quizzes are 20% of the grade to keep you engaged in them. That's not too much. And the quizzes are not meant to be hard. I'd be happy if everyone got 100% on all the quizzes, right? That's not meant to scale the grades in the class. They're meant to make sure you're paying attention to the class. The homeworks are where you're reinforcing the concepts you've learned and making sure you understand how to do them. Those are 60% of the grade. Homeworks, you should work, you can talk with other people about them, but the work itself and the write-up, so should be your own. Okay, and then the final will be 20% of the grade as well. Okay, and the final will probably be like a bunch of quizzes stuck together, whether they're on Canvas or they're on paper. The questions will be similar to the quiz questions. So you'll get some practice in what those are like as we're approaching that. Okay, the grade mapping is the standard. 90 to 100 is the A range, 80 to 90 is the B range. I'll typically stick with this. Usually, I'm happy if a lot of people get A's in the class. I will calibrate the difficulty of the material to what I think you should learn. And so if a lot of people get A's, I'm totally okay with that, right? But so I usually don't need to deviate from these things. Okay, and it's the standard mapping, kind of 0 to like 90 to 93 is an A minus, 83 to 87 is a B, 87 to 89.99 is a B plus. So that sort of thing. Lateness, the quizzes, there won't be any. You have to take the quizzes during the time they're marked. If there's extenuating circumstances that happens, you can let me know and we can figure it out. But the homeworks, there's a late policy. You can turn them in late. You will lose some points if you turn them in late. Okay. The first 24 hours period, that means that's a 10% loss. The next 24-hour period up to 48 hours, 20% loss. That means the maximum grade you can get is an 80, right? So if you got 5 off and you're, up to 48 hours late, then you would get 75 points total. Okay. So you can you make that decision if that's the right thing for you to wait a little bit longer to turn it in. Yeah.
So after 11:50, that's just 10% minus instantly, or
when Canvas marks it late, I'll go by the Canvas counter.
So that's 11:59, not 11:50.
It will go by the Canvas counter. Yeah. So it's due at 11:50, and that's when it's late. But I might be willing to give some slack based on Canvas. Okay. Yeah. Right. So it's kind of some mental tricks I'm trying to play in the open here, but they still work. So at least most of the time. Okay. If sometimes stuff is graded incorrect, that happens, let us know within 1 week of receiving your grade, and it's going to be reviewed. If you wait till the end of the semester, I'm not gonna look at for something graded 2 months ago. Okay, we'll try and get stuff back quickly. Again, you can discuss homeworks with other people, but the write-up and the work, and if you write any code, that should all be on your own. Okay, it shouldn't be, the coding should not be very much, so you're your own good to try and do this on your own. The coding is meant as to guide you along to getting used to Python. That's all it is. So it's not gonna be, I don't expect you to be spending hours trying to debug a program. It's mostly, okay, here's some exercises to keep you getting more and more proficient with basic stuff in Python to help enhance your learning of the other material. Again, all the stuff is there for you to help you learn the material better, right? If you do the homeworks, you stay on top of the quizzes and you watch the lectures, you're gonna learn better. That's what I want, okay? So I really recommend you try and do all the work yourself, because that's how you're gonna learn everything else about it. Okay, the school can be has a cheating policy. It's kind of a 2 strikes and you're out. So again, if you get caught cheating, kind of, you'll eventually not be able to take courses anymore in the department. Okay, and then there are a bunch of boilerplate here, and I used to think, okay, these are not, they're boilerplate. We'll go over them. I am going to go over them quickly today, but I come back to each of these in the other lectures because I think these are all important. But the thing is not to spend a lot of time on them all in the first class. So, there are resources. So I'll just go over them quickly now. Resources for students with disability or if English is not your first language. You can find it in the syllabus. It should be basically the same in all of your syllabus and your classes. We take sexual misconduct or other sort of misconduct and safety class very seriously. If you are on discussing homework and the discussion boards or in groups, this is an extension of the class. Don't engage in any behavior that will make other people feel so uncomfortable in the ways defined here. If you have a choice of name or personal pronoun, you put it in Canvas. I will try and I will respect that as much as I am as I'm knowledgeable about these things. So I will try and respect that. We are trying to be diverse and inclusive for people with who are coming from different situations and background in this course, and in the discussion, we're going to be respectful of that. And being in college can be stressful, and a lot of other stuff in life can be stressful. If you need help with wellness situation, there are a bunch of resources. Includes if you're a veteran, there's also resources available on campus. You can find a lot of these things in so on the syllabus. Okay, great. Let me say a little bit more about COVID in the next manner. So for the homework assignments, I kind of recommend doing them in LaTeX. This is kind of grandfathered in by myself, where I've been doing this for a while. I recommend LaTeX. It's now a lot easier if you use Overleaf, actually. It's what you see is what you get. It allows you to write mathematical notation in a way that looks elegant, the way it's supposed to look in a document. Resources for the Word over the last few years. So figure out ways so it's legible and clear. You're welcome to turn in any format. This recommendation is not as strong as it used to be, but you will be writing about the mathematics of data in this course, and LaTeX is kind of the original tool that made this really easy to do and possible. And a lot of the stuff within, say, Microsoft Word is based on LaTeX anyways, so that's my recommendation. But as long as it's clear and you're writing the notation the right way, the TAs can grade it, then that's fine. Okay. All right, let me say something about, okay, so how most of the lectures will go, all right, I'm moving, is I'm going to have my iPad open. You can see it here. You can see it on Zoom. It'll be recorded, and I will be so I will be writing on the iPad out the material we're discussing. We'll occasionally open something on Collab and show a little bit of code, but this will be the main thing. I typically won't have slides. Occasionally, I will pre-compute an example or something like that. I want to start off just talking about masks and so vaccines related to COVID. I think it's on some people's minds, so I thought I would give a little discussion about this. I did this last year as well, and I had to update these slides. So I'm not currently wearing a mask, and I'll discuss that, but I plan to wear a mask while I'm not lecturing, right? I like to speak without a microphone. Hopefully everyone in the back can hear me just fine. It's a little bit less easy to do that with if I'm wearing a mask, so it's kind of a personal trade-off. Okay, so are we back to normal? Okay, we also get to look at some cool data. One thing about the COVID is that there are a lot of interesting data with challenges in interpreting this data. Okay, so this is from the New York Times. This is the case counts. This was, when we first heard about February 2020, the Alpha variant, the Delta variant, so the Omicron variant, and then, so BA5, okay, which is the most recent variant. That's the dominant strain now. It's a version of Omicron, apparently. And so, well, okay, so the case counts are actually a bit as high, maybe higher than when we shut down campus in spring of 2020, okay? But that's not the only thing to look at here. If you look at the hospitalization rates and the deaths, this is spring 2020, the deaths were much, much higher, right? The deaths are lower now, but they're not zero. All right, this isn't completely over yet, but it is, it's much lower than this used to be. The other interesting thing about it is the case counts are probably a little bit kind of deceiving. Actually, around Omicron, when this was spiking, the US government sent at-home tests to everyone, right? And if you have an at-home test and you test positive, you probably don't, so call up the CDC and tell everyone you got COVID. So a lot of these cases are not reported either. A better guide of that is the maybe the hospitalization, but that has to do with the severity of the data as well. The hospitalizations are maybe creeping back up. We'll see a different picture of this in a second. The test positivity rate might be more interesting. Most tests are done when people are, say, admitted in the hospital for other reasons. They're often tested for COVID. And so the test positivity rate is pretty high. Not quite as high as with the peak of Omicron, but it's pretty high still. I suspect there's a lot of COVID going around, so right now. It's probably declining a little bit, and I believe these two. Okay, this is just for Utah. You see pretty much similar numbers. Some numbers are a bit less smooth because there's much more data for the full United States. And we'll see why later in the semester, why you should expect it to be a little bit bumpier and less, less smooth if you look at a smaller data set. Okay, but pretty much the same. Here's an important chart. This again from New York Times. This is hospitalization rate. And you see that, yeah, so hospitalization rate is still pretty high for like 70 plus. If you notice, it's important to break this down by ages, because most of you in this classroom are probably in this light green mark, and those rates are pretty low. Okay, the hospitalization rates are pretty low. They spiked during Omicron just because so many people had it, and they were higher earlier in the pandemic. Okay, so hospitalization rates are low. A lot of this is because of vaccines, and partially because these current strains of COVID seem not to be as dangerous as the previous strains. Plus, there's some over-the-counter, or some prescribed medicine you can get that will help treat this. Although that's no longer recommended for people under 50, I think, but unless you have certain conditions. So, okay, so for your age group, even my age group, I'm in the next level up probably. The hospitalization rates are pretty low, okay? Especially if you've had it before, if you've been vaccinated, should feel kind of reasonably safe. But if you're around others who might be kind of older or immunocompromised, you should be concerned about this, right? So I just want everyone to be kind of cognizant that there is still some danger, especially for people over 70. Their immune systems tend to kind of lose the resiliency they get from vaccines or the kind of earlier, more sooner. And if they've had a previous infection, their body will remember that a bit less. And so they're more susceptible to these things, and their just immune systems are typically weaker. Okay, so everyone at the University of Utah, you should be fully vaccinated. There are some exceptions, and not everyone is so fully vaccinated. If you are one of the few people who's not vaccinated and you kind of made it based on some personal decision, I recommend the vaccines a lot. They're one of the biggest life-saving things in the last 50 years. It's been a huge achievement. Most people in Salt Lake County are vaccinated, but not as many as I would like to see vaccinated. Okay. So there are a number of studies that shows the vaccines actually work. There's very little health risks for most people to vaccines. This is a study I like that came early. This is from Pfizer trials in Israel, mostly the Alpha variant. But what it shows is that the overall, so the efficacy, basically, were you hospitalized, was the ratio between the whether you be hospitalized, whether you had a vaccine or not, was like 67%. 67% of the time when you would have been hospitalized, if you didn't have the vaccine, you were not hospitalized if you did have 2 doses of the vaccine. This was Pfizer. But it's more stronger if you broke it down. They just did it less than 50 or greater than 50. And these numbers, if you break them down further by ages, they should be even more. So it should be like 90-some%. And with boosters, this should be kind of even stronger of keeping you out of the hospital. And if you don't have severe COVID, you're less likely to get so long COVID as well, right? Nowadays, we have we're on kind of effectively, I don't know whether the 10th or really the 4th major variant, BA4 and 5. And apparently they have a different structure which allows them to avoid the kind of your body's ability to immediately fight off COVID right when you're exposed to it. That's one of the core kind of features of these new variants. You can see as one variant, Alpha was the dominant strain, and then it was Delta, and you can see how it becomes almost everyone who had it had the Delta variant. Then it was this versions of Omicron. And as you can see, by June or July, it was almost all either the BA4, BA5, or this BA2.121, which had a similar sort of mutation here. And what happened is that your ability to neutralize it immediately and quickly went down dramatically versus even if you had had it before. This is a prior exposure, and you get only maybe a 10% increase. If you had BA4 and you had 2 doses of the vaccine, you're getting something like a 20 times increase. But with the 3rd booster, it was significant again, but it's much less kind of neutralization ability versus the previous variants, right? So a lot of people are getting reinfected. I've been infected twice, including recently, I believe, with one of these variants. So, it has this different thing. But however, the vaccines do tend to keep people out of hospitals, out of severe things. So they're still recommended. There's supposed to be a booster maybe coming out in a few weeks designed for these variants. I would recommend that if you have an option to get that. Okay, so one more thing. I think masks. So I think masks work. This is something I'm far less confident about than the vaccines. Okay, what you see, like if you read, I've read a lot of studies trying to kind of convince myself one way or the other. What is going on here? If you wear masks, right, they're kind of blocking these particles coming out of your mouth. This is kind of an exaggeration. COVID tends to travel though in these really small particles. This is one of the things that made COVID much different than other diseases in its ability to spread. These can stay in the air longer than can get through some masks. The KN or not N96, N95, KN95 or K94 masks tend to do a much better job of stopping these because they fit better around your mouth. The surgical masks do a pretty good job as well. If you're wearing a mask and it's not covering your mouth and your nose, you're not wearing a mask. Okay, so if you're going to do that, don't bother even wearing the mask probably. Okay, so I believe that it's hard to run studies on these things. I believe masks are helpful. The degree to which they're helpful is hard to kind of to quantify. There's a number of bogus studies going around the web, but it's hard to argue that they don't have any effect at all. Okay, they should stop the particles that are the size that are carrying COVID. They understand how small the particle needs to be, and they do stop most of those particles. Okay. Okay, so if you want to wear a mask in here, for all the reasons I said, you are welcome to wear a mask in here. Yeah, there's still some people who are more, more vulnerable. So if you are going to be exposed to people more vulnerable, please pay careful attention. We are a mask-friendly campus. Okay, so you're welcome to wear a mask. Wearing a mask when I'm not lecturing, when I'm around all these people indoors. You can get tested weekly. I think the main College of Engineering office has these, right? You can get vaccines and boosters on campus. There's more information here about how to do this. If you are exposed, we've already had an exposure in the, in the classroom, not someone who's been in the classroom. I will, but if you're doing that, you should, for at least 5 days quarantine, and we have ways that you can stay up to date on the class through Zoom and YouTube and everything through Canvas. Okay, so please still take it seriously because some people are still at risk. Okay, so that's what I wanted to say on masks and vaccine and COVID and stuff. Hopefully that's clear. Make your own personal decisions on your risk factor to yourself and others who you might be exposing it to. I assume probably a number of you will get COVID during the semester. It's just going to happen. Hopefully it's not too, it's nothing too severe. So, okay, great. All right, so that's kind of what I want to say about how the class will work. What I plan to do for the last half an hour or so class is trying to give you a kind of a basic tour of what you will learn in the semester in class. Oh, there's one more thing I wanted to do. Yeah, again, I want to encourage you all to come into class. Despite COVID, there's masks and probably your age group, you should mostly be safe. The benefit of being in class is not just that you can interact, you can see me flail my arms in person, but that you're going to meet people in class. One of the great things about the college experience is that you get to meet all sorts of other people with similar interests to yourself. These people are going to be friends for your lifetime. They're going to be co-workers. A lot of you will stay in the state of Utah, work in similar industry. Meeting and knowing other people is kind of a great advantage. What I want everyone to do right now actually is to kind of say hi to your neighbor and introduce yourself. I'll pause, just say hi and kind of, yeah. All right, great, thank you. So great, there's clearly up this big kind of desire of people to see other people. I hope this reminded you, seeing everyone on campus, remind you about this. You will enjoy this during the semester. Keep talking with people. It'll be kind of more time for this after and before class. This is great, right? So people on Zoom, hopefully you can come in the future times. So great. So all right. Okay. So this will give you let me give you a little bit of overview of this class and okay. So what we're goal to cover in this class, and this could be practice with my handwriting before we get into the important stuff. It'll be a little bit better as I get used to this again, is we're going to talk about kind of the language of data. The first half of the class is kind of be about the language of data, and there's going to be kind of two main, and then the second half will be about the kind of common techniques of how we process data, give you an introduction to machine learning and data mining with the most kind of common techniques within that, right? So the kind of when we think about a, we'll think about having some sort of data set X, often try and call the data set X, and this data set we'll think of as a bunch of these observations, okay? And so I'll write these as a set. So if you've had 2100, you've seen curly brackets mean it's a set of observations. That's X1 up to Xn there. Xn will typically have n data points, okay? And these will be, I'm gonna go through this quickly today. We're gonna go through this all gradually throughout the semester. So we draw an IID from some underlying distribution, right? So this is going to be a so this is going to be some sort of distribution. So we're making observations about some part of the world, and this distribution is capturing, okay, if they're about people, then what are people like, but also the process with which we made the observations. And we're going to say that these are sampled randomly from this distribution here. Okay, and so the fact that they're random and this IID, which is independently and so identically distributed, we'll spell that out in a couple of weeks. That means that these are randomly drawn, and we're going to have to reason about the randomness in here, and we need probability to reason about this. Okay. One of the main things we're going to say is say there's some let's say there's some property R, and we want to talk about, let's say, the probability that Xi has R. We want to be able to kind of formalize this notion. We want to say some property, maybe it's an inlier, an outlier, it fits the data, it fits our model well. What's the probability it has this sort of property? So we need to be able to speak in this language because we're going to assume the data is randomly drawn. It means we don't know the full world that this comes from. We're just looking at the observations. We need to make an inference about the world from that, and that is a random observation. So we have to use randomness and probability to discuss these things. One of the main things we'll be doing, looking in this class, and this will happen over and over and over again, is we'll do things like an average. So I'll say, what if I took an average over all of these observations, right? So X bar might be often written as the average. I sum up all the observations. That's a sum symbol from 1 to n, and I took divided by n. That's an average. What happens to my knowledge about this? Typically, the average of a bunch of observations works much better than a single observation, right? And we'll try and quantify how this is the case. Most of data science is about taking as many observations as you can and aggregating them together into one model. By aggregating, they're better because I get more observations, right? Models are somehow going to be like an average result of all of the data. So the more data I get, the more accurate this average is. And so we'll be talking about this property, about how you get more accuracy as you get more data. And again, probability, this is a probabilistic notion of how we have to describe this. So probability will be the first kind of probability is going to be the first pillar of the language so that we're going to use. Okay, the second one is going to be linear. So linear algebra. Okay, and linear algebra, if you've taken I guess most of you are supposed to take a course in linear algebra. This is a lot about vectors and matrices, right? So the vectors and so matrices. Why are these important? because if I think of a vector, let's say xi, that means I can represent it as a vector that could be xi1, xi2, up to xid, right? So one of my observations might have many attributes about it. Okay, I could think of if I'm observing something about a person in this class, during the course of the class, I get attributes. How do they do on quiz 1, quiz 2, quiz 3, quiz 4, all the homeworks? Each of those might be a score. And those tell me kind of, I put those together in some, sort of holistic way to kind of assign a grade at the end of the semester. Okay, the grades are assigned in a pretty straightforward way, but you could think of other sort of things I could make an inference based on all the data I've collected, right? If I have more than someone, not just a single value, I would often store it as a vector. A vector is kind of the representation of this. So we would say that this lives in kind of RD. So it'd be a D-dimensional vector. If you're a computer scientist, that's an array with D elements in it, right? So nothing too crazy here. And then we might also think of X, this uppercase X of all of the data. We could represent this as a matrix, actually. And usually I would do Xi or X1 transpose, X2 transpose. So now each of these rows is going to be a vector. And this comes down to Xn transpose, right? So if I have n data points, I might stack them together on this matrix, right? So this is one observation, the first row, second observation, the second row, and I stack them all together in one matrix. Why do I want to do this? Because I want to do things like averaging these things, right? If I have a bunch of records and they're multidimensional, then I need to be able to do some computation on them. As simple as averaging, but we'll see much more complicated things. And if I use the language of linear algebra, I can represent things as a single observation as a vector and a bunch of observations as a matrix. And then I can do computation directly on these things, and it will generalize our intuition from just one-dimensional values. That's kind of the power that we're going to get from linear algebra. Yeah.
What does transpose mean?
Yeah, okay, we will go through this in more detail, but the transpose is taking a column vector where I've written this from top to bottom, and I made it a row vector, so I've written it from left to right. How you represent it inside of a computer as an array, it makes no difference, right? And a lot of internal representations, they don't make a distinction. Occasionally, it will be a little bit be worth doing this. I'm someone who tries to ignore this distinction as much as possible. And so I will try and write notations. We often don't need to worry about this, in fact. Some other notation you'll find on the web will stress this more. They'll do things like write an inner product using the transpose operator, which I think is more confusing than it needs to be. Because internally, they're both just an array. But I like to think about data as being rows in a matrix. And I think then, again, that's a choice. I could have been the columns. Okay, so great. Okay, so if we represent our data, these vectors and matrices, it'll open up this kind of these computational tools, which we can generalize to any dimensional data, right? So if you think about data and you think about, okay, I can draw pictures in like things like a sum are simple to think about in 1D. I can draw pictures in 2 dimensions, right? Most of the class, I love drawing on the iPad because I can draw pictures for you all. I can do that in 2 dimensions, right? We can probably think and we move around in 3 dimensions, but data sets might be 100 or 300 dimensions. This is not abnormal, okay, or 1,000 dimensions. And I don't know how to think so clearly in 1,000 dimensions, but with linear algebra, I don't necessarily need to. I can know that the mathematics will still work. The algorithm will still work as long as I describe it in terms of linear algebra. Okay, so we're going to review some linear algebra, the kind of the core parts you need to know. And then the second half of the class is going to be all describing techniques using the language of linear algebra. And it's going to feel natural at that point. And you'll be dealing with really high dimensional data. And it's not going to be totally blowing your mind. Well, hopefully, I hope it blows your mind a little bit, but not kind of, you know, in a way that's good, right? Not in a way that you're totally confused. Okay, so this will be natural by the end of the semester, thinking about both the randomness of the data and how we kind of get better estimates as we get more data, and then how to think about high dimensional data in this very abstract way through linear algebra. Okay, and Python has a lot of built-in functionality to deal with both of these things. So you're not going to have to worry about implementing an array. When I was in college, whenever I wanted to do something like this, I had to, like, I often implemented my own array, and it was, you know, you won't have to do any of that painful stuff. It's built to, this is the natural format of the data. So, okay. Okay, so one of the other kind of important things to, yeah, so one of the other, once we get past kind of this notion of the language of data, we're going to talk about kind of 3 or 4 types of data analysis. And I think it's kind of helpful to draw these in a chart. Okay, and so we'll talk about 4 main types of data analysis. They're going to be, so clustering, classification, so dimensionality reduction, so reduction, and then so regression. So okay, and so we aren't gonna, this is a huge space of algorithms. There are new ones being developed kind of every day within these in these areas, right? This is where my research lies in developing algorithms like this. We aren't going to cover the total state of the art in this stuff. We're going to get kind of the core things, the most common techniques in each of these spaces. For clustering, we're going to look at the k-means formulation as well. So we'll see the Lloyd's algorithm for this, which is the most common, and this mixture of Gaussians approach. Mainly k-means is kind of the classical thing. For dimensionality reduction, we'll look at principal component analysis, PCA. This is kind of the most common way to do dimensionality reduction. For classification, you will understand, so linear regression, so least squares, so often called least squares, so linear regression. We'll also see versions with so polynomial regression, as well. And oh, I wrote this in the wrong spot. What am I thinking? Okay, so for classification, we'll look at linear, so classification. Okay, well, we'll mostly focus on this. We'll talk about the perceptron algorithm, which is a really cool, simple algorithm on how to solve the linear classification problem. But we'll also talk about things like using kernels to do nonlinear classification. And at the very end, we'll probably do a little bit on things like decision trees and so neural nets, so that you kind of get a see of where the more advanced things are going in this. You will know what they are at the end of the course. You will not be an expert in using these. We have a different deep learning class and a different machine learning class that can go much more in depth in these things. And in regression, we'll mostly look at least squares. We'll mostly look at least squares, so linear regression, but we'll get to see polynomial regression so here as well. I assume a number of you have seen versions of these before, maybe not all of them, maybe all of them, but it's less likely that you really understand how all these things work and why they work and how to really think about them at their core, and that's what this class will do. You will learn these at a very fundamental level, so you will be able to build on them to the more advanced sort of techniques. You'll understand something about the limitations of these techniques. So you'll know when this will work and maybe when it will potentially not work. So you would want to employ something more advanced, right? We're not just going to be taking a package from Python and just running these in the package. Most of these have very simple implementations, like literally a few line implementation for most of these. And so you will get to implement those and you will see how this stuff, how it actually works, right? And this, I think, is very informative to prepare you to do more advanced stuff. Okay, there's another kind of way of marking on this chart I think is useful. The first column is what's called supervised, and this is called supervised. Okay, and so what distinguishes these is for the unsupervised, you're just given a data set X, and for the supervised, you're given data set and some labels Y, right? So these are some labels. So for the supervised things, classification and regression, you're going to be using the data X that we were talking about on the previous slide to try and predict the associated labels Y, so that when you get new data, you can predict what the new labels are. And the fact that you have labels is essential for supervised elements. The unsupervised stuff, you don't have labels. You're just looking at the data itself. You're not necessarily trying to make a prediction. In fact, these are not phrased as making a prediction. They're looking at the structure in the data. Okay, as I like to say, you know, if you have kids and you leave them so they're unsupervised, it can, you know, you can have a lot of fun, but you can also get in a lot of trouble, right? And so these unsupervised methods are things where you have a lot less guidance on what you're doing. So you're kind of you're looking at the structure of this data, but it's less grounded. To supervise, you need this labeled information, and you use that to try and make a prediction. And those you can actually say much more about how accurate these are, and they've become much more powerful. Classification and regression is a lot of what's driving the impact of machine learning in business and society. But these things are very important. They're also heavily used, and they're often used as part of these advanced techniques. So they're still really fundamental aspects. Yeah.
So K means clustering. Does that require an input like K? Is that different?
Yeah, this requires inputs like K. It's not a label. Label is every data point you have a label associated with each data point. That's a general parameter. A lot of these things might have parameters in some similar way. So that's an interesting question. We'll see it throughout the semester. Yeah. All right. One other thing about these is that because you have labels, you're going to be able to evaluate these with a very important tool called validation. Okay, this is a method for allowing you to kind of determine how well your algorithm, your prediction is working. This is only available because you have this labeled data. And what you do is it's more common. It's a fairly recent sort of phenomena in the history of science. It goes back maybe to the 1960s or 70s with Heilemann, but it's kind of been dormant until maybe 20, 30 years ago. Whereas if you look at classical statistics, that's like 100 years old, right? Which is still pretty young in science, much younger than things like, things developed in, so physics is much older. Cross-validation, may be popular 20, 30 years. This is a new idea, and it's because we're able to capture and use computation to process a lot of data automatically. What you do is you take some of your data and you save it for later. You build all your model on some part you've used for training, and you keep a different part for testing, and you evaluate how well it's working on the data you didn't use for training. And we'll talk much more about this, but this kind of is essential to how to think about to evaluate how well you're working, and that's associated with these models which are so supervised here. Okay, this is a very powerful chat. You know, you probably haven't seen in a class up to this point, right? That's one of the key things you should get out, the learning outcomes you should be getting out of this class. Let's see, the other important distinction, why I put this in a chart, what's going on with the rows here. Okay, good, I put them in the right spot. So the clustering, this is learning kind of a set. I'm trying to learn how to put things in a set, put data in a set. I'm either trying to make a prediction of what set it's in. Is the sports team going to win or is it going to lose? Those are two options, right, in classification. Clustering is grouping sports teams into the ones likely to win, likely to lose, and likely to be somewhere in between, be something like that. But it doesn't necessarily have the labels in order to do that with. Where these are trying to learn a value instead, right? So like a continuous value. I have with regression, you know, I might predict what, you know, if it was a set, are you going to get an A or not A in the class? Regression would maybe predict what is the final kind of score you're going to get in class at Canvas at the end, right? That's trying to predict a value at the end. And dimensional reduction is starting with really high dimensional data and reducing the dimension of it while preserving this value information. Yeah.
So
Yeah.
going back to that, the team's idea with classifications, or if we do it for regression, would it be more like, can we predict the score that they're gonna have fighting this?
Sure. Yeah. So a lot of models, if you look at like in college football is a good example. There are a bunch of models out there that go into the ranking of the college football teams at the end of the season, and this determines what bowl game they end up going to. And actually the models they use for that might not be allowed to do that, but the models that work better at predicting wins, that people who are sports betting doing stuff, instead of predicting win or lose, they probably do better of predicting what the value or what the difference in the scores might be. And then if that difference is positive, that's a win. If it's negative, it's a loss. Predicting the value gives you a lot more precision you can work with. And you can always round that into a win or loss decision. And you'll see classification will actually do that. We'll actually learn kind of a value, and then we pick a threshold, and that determines which set it ends up in. So we're actually doing that in the other cases, but this one has a final mapping into a set, and this changes a little bit how we operate. Yeah.
We're going to more depth into all.
Yeah. So so a lot of this should be fast, and you're like, I don't totally get what you're saying. By the end of the semester, you'll look back on this and say, yeah, okay, I get that. I see how it fits together. I'd like to try and give kind of previews as you're going to give you some guidance of where we're going to be and how it's going to fit into the big picture. All right, one last thing I want to try and explain as an important concept is going to be gradient descent. Okay, gradient descent is the most important algorithm in data analysis. Okay, there are different versions of this, but almost all of the computation time, if you hear about machine learning needing these large GPUs, right, and using all this computational power and stuff, they're running versions of gradient descent is what they're actually doing. We'll see other algorithms which are not gradient descent, which are kind of more clever and give intuition of what's going on. But a lot of what's actually run under the hood ends up being gradient descent. It turns out there are versions of this. We'll see stochastic gradient descent, which is a version that scales to very large data sets. We're not going to go completely into all the types of optimization. There's a really cool optimization class in the math department here that will go into a lot more depth of these things. But gradient descent is the most important algorithm. Let me try and give a sense of how this fits together. Again, this is going to be kind of, you aren't going to get all this now, but it'll kind of give you some picture of where we're going. There are 2 steps to figure out how this works. The first one is to build a cost self-function, F, and this is going to be from a set of parameters to some score. These are going to be so alpha is going to be a vector of parameters. So I'll say alpha is going to be in a vector of size k. So it's going to be some k parameters, whatever k is. It could be 1, it could be 2, it could be 20, right? Different algorithms have different parameters. I want to learn the parameters which describes my model. Okay, so so I could think of this as f actually alpha or equals f of m alpha, and my model, this is the model, I'm going to get in a data point, and this is going to you know, predict, right? If its classification is predicting the, it's not showing up. Has there been this lag the whole time, or is this just now? Okay. Okay. I unplug it. I feel like I'm going to lose. It's not going to reconnect. Let me. Well, we're at the end of the lecture. This is a good challenge for me. Okay. Let me try and just toggle this. The setup to get everything working together is pretty complicated, but once I have it, it usually works pretty well. Okay, this is not connecting. Okay, I will say this in words, and then we'll just end the lecture. Okay, so we're going to build a model based on the data. What gradient descent does, it takes a function that scores how good is that model. That function is based on the data. Gradient descent wants to find the model that minimizes a cost function, a score. It says this score tells me which model is the best, and gradient descent takes the derivative of the function and moves in the direction that decreases the value the most. So I need calculus to take the derivatives. In everything we do, the derivatives are going to be really easy. There'll be partial derivatives, but they're going to be really easy. And we're going to use this to move in the direction of steepest descent, get to the optimal model, and that'll be kind of the core, the core algorithm used. So we'll spend several lectures on this as well. Okay, so that gives you a pretty good preview of the class. I will see you on Thursday. Don't forget the first quiz will be on Thursday. Bring your laptops, will be on here, and hope you come to class. Okay, let me try and before I chat, let me turn off the Zoom recording. I know what happened. My laptop ran out of batteries. Okay, let me just